Hi everybody, my name is Matthew Poes of Poes Acoustics, and in this video I'm going to talk about gain in a couple different ways. So all processors have to deal with this, but most processors lock you as the end user out of a lot of these capabilities for the reason we're going to discuss now. And that had traditionally been true and then suddenly started to be not true. And so the capabilities I'm talking about is the ability to adjust things related to the gain or the output, including EQ boost. So let's just start with gain matching as a concept and then get into some of the other issues. Gain matching is the idea that you want to set the amplifier's input stage sensitivity such that when the preamplifier is at its maximum, couldn't get that one out, it is at its maximum clean output, it's driving the amplifier to clipping. That way, you're able to drive the amplifier to clipping no problem, and you're not driving the preamp into clipping too. You want that to be set up just right. And there was some industry standards that kind of came about that set, for instance, single-ended at between 2 and 2.5 volts. That's very common voltage outputs. And so the sensitivity of, I think it's 29 dBs or so, or 30 dBs of input gain allows most amps to be driven to max output at 8 ohms with that much voltage output on the preamp. And you need less with 4 ohms, and so you have more than enough in that scenario. But you run into a problem, which is why we don't follow that standard blindly and why better products actually don't follow it at all. And that is, you take the given output and noise of your preamp, which is fixed at this point, and then you boost it by 30 dB. You've boosted the noise by 30 dB. Now, if the noise output of the preamplifier is, let's say, minus 130 dB, and you've boosted it 30 dB, then now we're at minus 100. Still pretty good. But what if the noise was minus 100, and now it's 70? That's not minus 70. That's not very good, right? And that's very simplistically what happens. And so the noise and distortion levels of the system, the amplifier and the preamplifier, end up being made much worse if you do that. So a better way to do it is to minimize it so that the input gain on the amplifier only needs to be like 15 to 20 dB. And the output of the preamplifier is much higher. It's not 2 volts, it's 4 volts or really 5 volts or more. If we could get 10 volts out of it and keep it all clean, that would be great, right? And we would do that. And there are products that have gone down that road. Mark Levinson was an early proponent of that with their products, and we now see that with other products. Trinnov does that with theirs as well. Okay, so here's what can happen if you take an amplifier that has fixed gain, and we'll just say it is 30 dB or so, and you take a preamplifier and it has very high output, it's going to push the amp to clipping earlier. But that's not a problem because it just means it's louder sooner. But where you can run into problems is when you start to, well, first off, something to keep in mind. Turning the output voltage of the preamplifier up doesn't make the system play any louder. It simply makes it hit its maximum loudness sooner. And so there is no real reason to do that. And doing so could potentially, because now you're kind of doing the same thing as boosting the input gain on an amplifier, could boost noise. So you don't want to just boost things for no reason. So something I have seen people sometimes do is they take their preamplifier and they just max out the gains on it. No real reason to do that. Worse yet on the amplifier, you should not be maxing the gains on the amplifier. You should actually be lowering them to the lowest setting you can get them at and still clip the amplifier. But then we get into where, so one of my friends, Ross Taylor from Absolute Ultimate AV, had brought this up as something to cover, why you shouldn't do that with the EQ specifically. So you can take PEQ, let's just say you have a subwoofer, and it's in-room response. You know this is like a good subwoofer. And its in-room response is, unfortunately, for whatever reason, minus 16 dB at 20 hertz. And you want it to be flat to 10 hertz. So you decide to add about 20 dB of gain at 18 hertz with a PEQ filter, and it's got a Q of 1. So it's a nice wide, that's a low Q. So it's a nice wide bump. Boosting it up, it's below 20 hertz. So your 20 hertz, you're going to be probably boosted at that point. You'll be above flat. And below that, you're flat, probably not at 15 hertz, right? But you added a ton of gain, basically, with that EQ filter. you're now going to cause the preamplifier to clip much sooner. You also risk overloading the amplifier. So that much output at 20 hertz could cause the amplifier to clip. And you've now lost output. If there's content at 20 hertz, at least with that much boost, you've now lost output in terms of total output just to get it to measure flat in a way that, quite frankly, probably isn't that audible. So you've made the system worse in every way to make something that's not as important better. What you really needed to do in that scenario first would be to make sure everything can handle that. So if you're going to add, let's say, 15 dB of gain, you really need to subtract that somewhere else in the signal chain to get that headroom back. Otherwise, you're just taking away a lot of headroom that you had. Now, in many systems, you can't do that. They automatically do it to a point, but there's a limit to how much they can do. And so typically, to avoid losing headroom, even with like a Trinnov or a Storm, we don't recommend going past 6 to 10 dB. Something that we've noticed, I saw this on the ISE system. I've seen this with my own systems I've tuned. When trying to boost that response down to 20 hertz and below, even if the subwoofers can technically handle it, does cause a rise in distortion. And it may not be all that audible, but of course that's signaling that you're also causing a hitting towards the limits of something sooner. And that can be in and of itself a bit of a problem. So what I've noticed is that when you really get an aggressive amount of boost there, it might measure impressively, but that distortion is rising. That is not so impressive. It could be a sign of a bigger problem. Now, if that distortion rise remains under 5 or 10% at some very loud level, like 105 or 110 dB, I don't think that's a major concern. It just means that you are pushing it into its limits, at the limit of where you're going to be playing it. On the other hand, I've seen systems where you're at maybe 75, 80 dB, and distortion has risen now from where it's maybe under 1% at most frequencies or around 1% to suddenly now it's about 10 or 15%. There's no way you're going to hit reference levels anymore with that system because you're going to have driven that subwoofer well into clipping and compressing because of that boost at 20 hertz that you've applied. So you don't really want to do that. You want to be very careful with how you apply EQ. So that's the whole, like, why we don't want to overdo it. That's the most common area you see it. Now, of course, there's other areas where you don't want to do that, and that is if there's a null. So you don't want to fill in nulls. People hear that all the time. The reason you want to fill in nulls is essentially a null is caused by cancellation. It's actually the smoothing of the response that makes nulls look like they don't go on for infinity, but a true perfect cancellation at a particular frequency will go on forever, and no matter how much sound energy you put into it, because of what's canceling it, it'll always be equal and opposite. It will always be 100%. In fact, even if the wave that's canceling it is not completely equal and opposite, it's 90%, adding all that boost is only slightly fixing it. So it's really not a good idea to do that. You're just basically putting, good money after bad. So you're just pouring in tons and tons of sound energy you really need for other things into something that, quite frankly, probably isn't audible. And even if it is, needs to be fixed the proper way, not with EQ. So that's another scenario where just boosting is not a great idea. The other thing I'll mention is that the peaks and dips in the response of a system, it's not like they're all equally audible. In fact, when you add in the issues of masking, in many cases, a system response can be pretty lumpy and basically sound just as good as one that's dead flat. And so even though you can take a tone, for instance, and you can add a resonance to it that's very, very small and pick it up under ideal conditions, in a proper surround system while listening to music or movies, that isn't true. And that's because the masking effects that take place in those scenarios largely get rid of how audible some of those peaks and dips are. Some, of course, are more audible than others, but as a whole, it's not something to be too concerned about. So my advice to you guys is don't just boost the crap out of something. We don't want to be adding tons of gain for the sole purpose of making it louder. It doesn't really work that way and ultimately leads to a bad sounding system. Everything should be done carefully. I typically recommend 6 dB of boost max with most systems using most what we'll call pedestrian equipment. When you've got really, I have these 4 RTJ18s, and they don't actually extend to 5 hertz in room. They do roll off a bit in room. But I also know that between the very high excursion, the very high power, and the fact that they are overkill for this room, that they can handle a bit of boost. I know that because we've actually tested them, and so I know how much headroom is there. So I would be comfortable adding a bit, 10 to 12 dB, in the low end. Even I wouldn't go past that though. I would not add 20 or 30 dB of boost at, for instance, 5 hertz just because I want the thing to look flat in room at 5 hertz. My room doesn't support that. Those subs are not going to do that, and I'm just going to add a lot of problems. So it's just not worth it. So hopefully this is helpful. We've enjoyed this video and provided some insight into how to EQ a system and what kind of safety margins you really want to include in that. Subscribe to my channel if you haven't already, and you'll get notifications when the videos come up, and I'll keep producing them. Thanks.